Question 10a. Copy and complete the table below for the relation y equal to s squared minus 2s minus 3. You have the table of values with some missing y values and you are expected to get them. B part of the question, draw the graph of the relation in A above using a scale of 2 cm to 1 unit on x-axis and 1 cm to 1 unit on y-axis. Hence, determine the roots of the equation s squared minus 2s minus 3 equal to 0. Part B is 2 in 1. C part of the question, using the same axis, draw the graph of y equal to 2 minus 2s. This one is linear graph. D part of the question, deduce the roots of the equation s squared minus 2s minus 3 equal to 2 minus 2s. That is the points of intersection of the curve, and the line is the root of that equation. E part of the question, find the minimum value of y equal to s squared minus 2s minus 3. Solution. In order to plot the two graphs, we need to complete the table of values for the quadratic and linear function. Table of values for y equal to s squared minus 2s minus 3 over the range of values of s. You have values of s already. To get y values, you need to get s squared and minus 2s precisely. To get s squared, you need to square each value of s. If you square minus 3, you have 9. Square minus 2, you have 4. Square minus 1, you have 1, and so on. To get minus 2s, use minus 2 to multiply each value of s. So minus 2 times minus 3, you have 6. Minus 2 times minus 2, you have 4. Minus 2 times 10, you have minus 10. Minus 3 is a constant, and as such, you write it under each value of s, as you can see. To get y value, you need to add down. 9 plus 6, 15. Minus 3, you have 12. 4 plus 4, 8. Minus 3, you have 5, and so on. Now, let us jump to C part of the question and also construct the table of values for the linear graph. Y equal to 2 minus 2s, using the same range of values of s. 2 is a constant. You write it under each value of s. To get minus 2s, you multiply each value of s by minus 2. So the same thing you have here is what you have here. To get y, you simply add. 2 plus 6, 8. 2 plus 4, 6. 2 plus 2, 4, and so on. We continue by plotting the quadratic equation graph first. Okay, so we start by restating the scale. The scale is 2 cm to 1 unit on x-axis and 2 cm and 1 cm to 1 unit on y-axis. This scale implies that one line is equal to 0.1 units on x-axis and 0.2 units on y-axis. Now, this graph I'm using, you have the boss is 5 lines. Each boss is 5 lines. By default, it is 1 cm. So on the x-axis, you combine two bosses and give it 1. The next two bosses becomes 2, and so on. If you move to the left, you have negative values. On the y-axis, the end of the first boss from the origin is 1, next one is 2, you have 3, 4, 5, and so on. When you move down from the origin, you have -1, -2, and so on. Next thing is to plot the various values. The first one, when s is -3, y is 12. So 12 minus 3, this is the point of intersection. -2, 5, this is the point of intersection. -1, 0. When y is 0, s is 1. You plot that one directly on the x-axis. When s is 0, y is -3. You plot it directly on the y-axis. 1 minus 4, this is the point of intersection. 2 and -3, this is the point of intersection. When s is 3, y is 0, you plot that directly on the x-axis. 4 and 5, this is the point of intersection. 5 and 12, this is the point of intersection. You always include the title of the graph. For now, it is the quadratic equation. Next thing is to join the various points together. Now, all the points have been joined together. In that question B also, you are asked to determine the roots of the equation x squared minus 2s minus 3 equal to 0. This is the equation that you have plotted, and as such, no further simplification is required. The roots of the equation are the point of intersection of the curve with the x-axis. The roots are -3, -1 or 3, -1 or 3. We move to see part of the equation. You are to plot the linear graph on the same axis. Already the table of values, we have done it earlier, so you bring it in. The first point there, -3, 8. This is the point of intersection. Second point, -2, 6, somewhere here. -1, 4, somewhere here. 0, 2. When s is 0, y is 2. You plot that directly on the y-axis. 1, 0. When s is 1, y is 0. You plot that directly on the x-axis. This is 2 minus 2. You have 0.3 minus 4. This is 0.4 minus 6. The last point, you can discard it. Already the line has intersected with the with the curve from the way it is. Next thing is to join the points together. And the title is updated to reflect the linear graph. At this point, the points from the linear graph have been joined together. Hence, you are asked to find the roots of this equation. If you observe very well, this is the curve and this is the straight line, the quadratic and the linear function. The roots are the points of intersection. One point is here, another point is here. You trace this point to the x-axis, you have it somewhere here, and it is in between minus 2.2 and minus 2.3. In between must be minus 2.25. You know, on the x-axis, we said that one line is 0.1 unit. If you trace this point up, it's also in between 2.2 and 2.3. The middle becomes 2.25 as the roots of the curve and the line. E part of the question, find the minimum value of y equal to x squared minus 2s minus 3. That is the curve. This is the minimum point on the curve. If you trace that point to y-axis, you have minus 4 as the minimum value.